Imagine getting a nasal spray in the fall months that protects you from several respiratory viruses, including COVID-19 and flu, as well as bacterial pneumonia and early spring allergies. A vaccine with no syringe or injection. Animal research can help us to develop less invasive therapies while increasing protection. Let me tell you how. Researchers from Stanford University have developed a nasal vaccine that protects mice against a wide range of respiratory threats. Vaccines can help our immune response by presenting some fragments from viruses or bacteria to our immune cells. These fragments are sort of molecular puzzle pieces that are called antigens. When presented with a new antigen, our immune cells recognize their shape and create antibodies that match them. Some antibodies directly block pathogens from causing the disease, while others serve as molecular beacons to mark the invader to be destroyed. However, many viruses and bacteria mutate rapidly, resulting in antigen shapeshift. This happens often in the case of influenza viruses that cause flu. To overcome this obstacle, researchers changed the framework. Instead of creating a vaccine to target a specific pathogen, they develop a combination of molecules that mimics the signals that immune cells use to communicate to each other during an infection. During respiratory infections such as SARS-CoV-2, immune T cells in the lung produce certain molecules that activate toll-like receptors, proteins that sense and recognize pathogens, or innate immune cells which fight infection. The new vaccine mimics this process. It also contains a harmless antigen, an egg protein called ovalbumin or OVA, which recruits T cells into the lungs to maintain the innate immune response for weeks to months. In this study, transgenic mice that respond to respiratory infections were employed. Mice were given a drop of the vaccine in their noses. Some received multiple doses given 1 week apart. Each mouse was then exposed to one type of respiratory virus. With 3 doses of the vaccines, mice were protected against SARS-CoV-2 and other coronaviruses for at least 3 months. The vaccine even prevented the dramatic weight loss that infection causes otherwise. Even more, vaccinated mice were also protected against common bacterial respiratory infections caused by Staphylococcus aureus and Acinetobacter baumannii, which are commonly acquired in hospitals, and a protein from house dust mites, a common trigger for allergic asthma. The researchers will now proceed with a phase 1 safety clinical trial. If the vaccine is successful in humans, this work could be a paradigm shift in how we face preventive medicine